So you're welcome guys to the second MCQ for carbohydrate metabolism. My name is Dr. Onos. So the first question says, during the myocardial infarction, the oxygen supply to an area of the heart is dramatically reduced, forcing the cardiac myocyte to switch to anaerobic metabolism. Under these conditions, which of the following enzymes will be activated by increasing intracellular AMP? The answer is phosphofructokinase 1. So we told you guys already that PFK1, it's activated by high levels of AMP and inhibited by high levels of ATP and citrate. So, and also it is stimulated, which overrides every other inhibition, by the presence of fructose 2,6 bisphosphate rule. So you can go back to our glycolysis lecture and review that. Question 2. A patient has been exposed to a toxic compound that increases the permeability of mitochondrial membranes to protons. Which of the following events in liver cells would you expect to occur? So when this is electron transport chain. This is the inner mitochondrial membrane, the outer mitochondrial membrane. This is complex 1, where NADH is transferring the electrons from to coenzyme Q. This is complex 2, where FADH2 transfers to coenzyme Q. From coenzyme Q, we go over to complex 3. So this is complex 3. From complex 3, we give cytochrome C, from cytochrome C to complex 4. And this process of transferring electrons from complex 1 produces protons here. From complex 3 produces electrons here too. And from complex 4, there's electrons here. So there's an F0, F1 complex here that produces ATP synthesis. It requires the proton gradient to be able to synthesize ATP. So this is 1 again. This is complex 2, complex 3, complex 4, and coenzyme Q. So the question says, a toxic compound was given that increases the permeability of the membrane to protons. So what it means that this toxic substance is likely called an uncoupler. So what uncouplers do is that they deprive the protons from going through the F0, F1 channel to synthesize ATP, and they drag them into the cell, into the matrix, just like that. And this will prevent ATP synthesis from occurring. And this will not tell the body that it's as if you are not creating protons enough. So the process of oxidation will now increase, and at complex 4, oxygen reacts with the electrons and form water. So there will be excess consumption of oxygen. So that will be the answer. Increase oxygen utilization as a result of this toxic substance that is coupling with the protons and making it permeable, or making the mitochondrial membrane permeable to the protons. So question 3 and 4. A 40-year-old African American man is seen in the emergency room for a severe headache. His blood pressure is 180/110, that's high, and he has evidence of retinal hemorrhage. An infusion of nitroprusside is given. Which of the following enzyme is affected most directly by the active metabolite of this drug? The answer is guanylate cyclase is the answer. So question 4 now. When nitroprusside is given in higher than usual dose, it may be accompanied by addition of thiosulfate to reduce potential toxic side effect. Which complex associated with electron transport chain or oxidative phosphorylation is most sensitive to the toxic byproduct that may accumulate with high dose nitroprusside? And that's complex 4. So the answer is cytochrome AH. That's also called complex 4. So don't forget, I told you guys that 1 plus 3 gives us 4. So, and 2 plus 1 gives us 3. So this one is for complex 3. So the answer is complex 4. Question 5 now. Anaerobiosis leads to lactate formation in muscles due to which of the following? It provides substrate for glyceraldehyde 3-phosphate dehydrogenase. So when there's anaerobiosis with excess lactate formation, the levels of NAD builds up. So it builds up like this because as lactate is being formed, the NADH is utilized. So pyruvate utilizes a lot of NADH now and forms a lot of. So when we have lactate in excess, now this NAD plus now favors the conversion of DHAP to glyceraldehyde 3-phosphate. So that's why the answer will be providing substrate for glyceraldehyde 3-phosphate dehydrogenase. So that's the enzyme here. The enzyme that converts the HAP to glyceraldehyde 3-phosphate is called glyceraldehyde 3-phosphate dehydrogenase. It uses NAD plus and makes NADH here. So that's the whole reaction here. Question 6. A chronic alcoholic, while out on a binge, became very confused and forgetful. The police found the man and brought him to the emergency department. Upon examination, he displayed nystagmus and ataxia. Which enzyme is displaying reduced activity in the brain of this man under this condition? It's alpha ketoglutarate dehydrogenase. It's an enzyme that also requires tender loving care for Nengi. So the T here is thiamine, and chronic alcoholics, they lack the vitamin thiamine. So the enzyme not working here is alpha ketoglutarate dehydrogenase. Question 7. A newborn displays lethargy and crying episodes. Blood analysis indicates lactic acidosis and hyperalaninemia. In order to distinguish between a pyruvate dehydrogenase complex deficiency and a pyruvate carboxylase deficiency, one can measure which of the following in the blood. Fasting blood glucose level can be used, because if pyruvate carboxylase is deficient, the glucose level will actually be low. Question 8. A family that had previously had a newborn boy die to a metabolic disease had just given birth to another boy, small for gestation age and with a low APGAR score. The boy displayed spasm a few hours after birth. Blood analysis indicated extremely high levels of lactic acid. Analysis of cerebrospinal fluid showed elevated lactate and pyruvate. Hyperalaninemia was also observed. The boy died within 5 days of birth. The biochemical defect in this child is most likely due to the E1 subunits of the pyruvate dehydrogenase is not working. So the thiamine subunit, that's the part of the enzyme that was not working well. This enzyme is also a tender loving care for Nengi enzyme. It requires these coenzymes to function and has 3 units, E1, E2, and E3. So it's the E1 subunit that wasn't working. Question 9 now. A pair of farm workers in Emoha was spraying pesticides on crops when they both developed the following severe symptoms: heavy labored breathing, significantly elevated temperature, so take note of this, and loss of consciousness. The pesticide contained an agent that interfered with oxidative phosphorylation, which most closely resembles which of the following known inhibitors? The answer is dinitrophenol. So 2,4-dinitrophenol was actually the insecticide that they were using. It's not rotenone. What gave it out that it's E is actually significantly elevated temperature. Dinitrophenol is an uncoupler. So similar to the question we looked at before, an uncoupler would drag the protons and take them back into the matrix without going through the F0, F1 channel, and that would, instead of us making energy as ATP, the energy will be lost as heat. So this is significantly elevated temperature because of the energy being lost as heat. Other examples of uncouplers is thermogenin and high dose aspirin. So question 10 now. One of these is not a coenzyme for pyruvate dehydrogenase, and the answer is pyridoxal phosphate. So vitamin B6 has no business here. So we have tender loving care for Nengi. I know you may say, what about pantothenic acid? It is actually what makes coenzyme A. That's the C part here. So that's it with this MCQ. Thank you guys.